I'm Poornima Nair. I'm a freelance .NET developer, and I've been with Umbraco for quite a while now. So before we start about minimal APIs, let's think about the world where minimal APIs did not exist in the .NET realm. We had this program.cs class, which used to configure the web defaults for us, set up the IIS support, set up Kestrel. All that thing is done through this program.cs class. And then we had our startup.cs class, which used to set up all the services and also the middleware for us. So that's quite a bit of boilerplate code going on there. Now imagine a developer coming in from the Node.js world trying to set up an API. So this is how it looks like in Node.js for a developer in Node.js world. In Python world, it looks like this. And in Go, it looks like this. So there's one common functionality or feature here, the number of lines and the number of files it takes to actually create an API from the word Go. This was rightly pointed out by someone in the community when someone tweeted about a distributed calculator app where each function of the calculator app was done in a different language. And someone there pointed out, hey, this is all good, but do you know with .NET and C# that takes the maximum number of lines of code, maximum number of files, as well as a lot of boilerplate code going on to actually set up an API. That was the much needed push for Microsoft as well at that point. So if you consider the developer experience for first-timers or adopters coming in from some other programming language into .NET, it wasn't very friendly because we had a lot of boilerplate code to get through, as well as it set a very high barrier to entry as well. You can't really just start and say, I want an API up and running. So the coding becomes a ceremonial process. There's lots and lots of code to get around. So at that point, Microsoft had this big push from the community, and they went on to do a study, and David Fowler came up with what is a prototype called Feather HTTP, which led to what we have as minimal APIs today. With minimal APIs, the concept is you build APIs with the minimal components. With the most minimal components, you get an API up and running. And with .NET 6, when minimal APIs was introduced, there was a big push on .NET adoption amongst first-timers and beginners. There was a real focus on getting it easier for them. So this was a very good point or starting point for that. And talking about those three components which makes up the minimal APIs, the first one is the minimal hosting model, which was introduced in .NET 6. Then we have the web application and web application builder classes, which does a lot of heavy lifting in much simpler APIs for us. So all that what program.cs and startup.cs did for us, that's all done in a much simpler API using these classes. We still have to register our services and have a middleware set up, but the boilerplate code has condensed down a lot. And in .NET 6, we had the new routing APIs, the map methods, which not only gave us endpoints, but also to map services like controllers or gRPC service or SignalR service. All of that came in with this map methods or these extension points. So let's see some code in action now. If I can see my taskbar. Taskbar, there we go. Okay, good. In time for demo, my mouse is not working. Let's see how far I can get though. So what I have here is a ASP.NET Core empty template, and we'll start building the API step by step. So as you can see, it's an empty project with nothing but the program.cs. So let us start introducing the minimal hosting. So we have the web application.create builder, which gives us a web application builder class instance, which is responsible for setting up the services, the login configuration, and all a DI container. Everything that needs to go into the DI container is also in the builder class. Then we build that web application builder class to get an instance of the web application. And on the app, the web application class, which implements the iEndpoint route builder interface, there are extension points, the map methods, which are the new routing APIs which .NET 6 gave us. And there you go, that is our first minimal API in place. And each of these map methods accepts like a route template and a delegate, which goes in and does the heavy lifting for you. So what these map methods essentially does is tie up your request delegate to your routing system in ASP.NET Core. And finally, we have app.run. So at this point, I should be able to run this without any errors. And I should be able to go into that endpoint using Postman and say hello to my API. There we go. We have something coming back from our minimal API. So we saw about the map get method. There are corresponding map methods for other verbs as well. So that is that. So if I go here, sorry, not that one, the map verbs. I jumped there. So we have the map post method, we have the map put and the map delete method, again taking a route template and a request delegate as well in place, which goes in and handles whatever you need to do for it. So that request delegate, that handler, that route handler, that is what is called in minimal API, that runs only if there is a matching route. So if ASP.NET Core routing system finds a matching endpoint for the incoming request URL, and you can also provide parameters. If the parameters match up as well, then your request, the route handler runs and gives you something concrete. So that is post, put, and delete. We can also have endpoints mapping to other HTTP verbs like options or head. If you want that, you can use the map methods, which accepts the verb that your endpoint should kind of respond to as well, in addition to the route template as well as the handler. So that is map methods. So far we've been using inline lambdas, but we can use something like a lambda variable as well, like so. So I can have a lambda variable and use that as my handler. That is possible. I can have a local function as well. So I can have a local function and use that as my handler. I can also have a method class and use the instance method or even a static method as my route handler. So if I go in here, method class, so that's my method class. I've got an instance method and a static method, and I can use that as my route handlers as well. So all of this should work. Now, we are talking about an API, and it would be good to have this documented using OpenAPI. We can have that in place as well using the middlewares that we are all used to. So for that, we can set up Swagger, swashbuckle.ASP.NET Core, and then have the services registered and my middleware setup as well. So this is exactly like how you would have this service and middleware setup in a normal ASP.NET Core application. If I build and run it, not yet. Go, it should run. So let me go in and have Swagger as the start URL. There we go. We have our Swagger definitions smiling at us, and I should be now able to invoke any of this with my friendly OpenAPI documentation that's been generated for me. Now, before I forget, let me go in and add Swagger as the launch URL. I should pick that up as for me. Now, this is an API. We can have course middleware in place as well if you want your API to be consumed by external clients. So let's have course as well in place. So right now, I'm adding a course policy which is pretty open, which allows any header, any origin, or any method out there. And I can have the course middleware in place as well, which registers the middleware, and now my API is at a point where external clients can consume it. I'm not going to go into testing that because I need to get through a lot of my talk today. But the point is that any standard middleware that you have in ASP.NET Core, that can be used in minimal APIs as well. Now let us get around to building a real world API, something like a little person database, which has like a little in-memory list, and then there's an API which does CI/UD operations on that in-memory list. So the first thing I need for that is my model, which will be a person class. And I've got some code here. My person model is a very simple class with ID, name, and the person, whether he or she has a pet unicorn. So that's my model. And I also want a repository so that I can do some CI/UD operations and kind of abstract away a lot of code for me. And I'm setting up that as well. So that's my in-person repository. What it has is an in-memory list of some people that I've already got in place. I have a create endpoint or create method which adds a person to the list, and then your standard methods that you would see: get all, get by ID, update, and delete. So I have this repository in place. Now what I can do is I can register this repository in my services. I am registering it as a singleton because I need a single instance of person repository to be available across all my requests. Now, let us start building the API one by one, the endpoints one by one. The first thing I'll be thinking about is a get all list of persons. So get all the persons in that list for me. And I'm using the map get method here. So there is the route template, but as you can see, my route handler also has a parameter, the person repository. What happens in this case, the parameter binding kicks in. So by default, the routing system can go in and search in many places and bind from many places or many sources. And the DI container happens to be one such source where it can look for the information that it needs. So if I simply put a service which I've already registered in my DI container, the routing system will resolve that parameter from the DI container. I don't need to explicitly say that, hey, go look for the repository or the person repository in my DI container. So that is inferred parameter binding from the services in the DI container going on for you. And once I have that inferred, I can use the getAll method to get me a list of all people in that list. So let's run this and see. It should work. What's going on here? Try it out. And I have the list coming back. It's my in-memory list that is coming back. We can take this further. Now let us think about getting a person by their ID. So this has few more things. Let me just resolve this as potential fix. It's got the repository there, which it is trying to resolve from the DI container, but it also has an integer ID, which it is trying to gather the information from somewhere. And in comes the route template, the route parameter in the route template, that is ID, which is constrained to be a type of integer type. So route templates and route URLs, the route parameters, is another place where the routing system can go in and check where to bind that parameter from. So in this case, we have an ID coming in the route template. So the ID value will be bound from the route template. So that is inferred parameter binding again going for you. And once I have the repository, I can get a person, and if the person is not null, that is if I find the person, I send back the person, and if not, I say not found. But then again, there's something called the typed results here. It's something new in .NET 7. So pre.NET 7, that is in .NET 6, what a minimal API used to return was an iResult interface. So it was not a concrete type. So it was not testable. The community complained about it. And so Microsoft came up with this typed results, which is like a static class, which returns a concrete implementation of an object which implements the iResult interface, making your APIs more testable. That is one thing. But the typed results has another advantage. When the response goes back, the metadata about that response is automatically gathered into your OpenAPI documentation for you. So in this case, I am sending back two different types of results, the type results.ok and type results.notfound. So because I want to write minimal amount of code to support that in OpenAPI, I'm using this generic union type, not found or OK person, that is going to be my return type. And this makes sure that the OpenAPI has the response metadata that I'm looking for from my API. You can always add the producers type and you can keep adding things, but we have better ways of doing it in .NET itself now. So if I show you what that means, I should have my get by ID here. If I go here, I see the metadata about the responses as well, which is quite useful because API should always be documented. So that is get by ID. We will talk about post as well now. So I'm using the map post method to create a person. We again have the repository which gets inferred from the DI container, but there's also the person object, and that gets inferred and bound as a parameter from the request body. So the request body is another place where it can go look for information and bind that to get the parameter. And once I have the parameters inferred, I can use the repository.create to create a person. And the typed results.created, what it does is it sends you back the newly created person as the response in the response body, but it also gives you the URL of the newly created person in the location header. So that is post. Like that, continuing with map put and map delete, we can have these endpoints in place as well. So that is building a little minimal API in .NET 7. But moving on with the slides, we spoke about parameter binding, but to have that in place, parameter binding means it's a process by which whatever comes in as the request data is kind of mapped to your route handler parameters. It can be inferred or explicit. I have shown you inferred examples. And by default, there are these many parameter binding sources. It can bind by default using inferred method from route values, query string, header, request body, the services, or you can even create a custom binding source. If you want it to be explicit, say if your route handler has an ID and a name and you want the ID to come in from the route and name from the URL, say, you can go for the attributes and decorate your parameters in your route handlers as well. So that's parameter binding, but then there are special types which are inferred by default and available for you to use in your route handlers. So these are bound without any explicit attributes, and it can be used in your route handler straight away as a parameters. So the first one is HTTP context, which contains the contextual information about your request and response. You have access to HTTP request and response. You have access to any cancellation tokens that you want to send in from your client. You also have access to the claims principal object using which you can get the identity of the user. So if you're playing with authentication and authorization, the claims principal object is there for you to think about. And minimal APIs in .NET 7. So we had .NET 7 releasing last week, and minimal APIs is one of those features or frameworks which got a lot of updates. I'm not going to cover all that today, but I can cover some of that today for you. We saw about the typed results, which gives you a concrete implementation of an iResult interface, which helps you testing and have the response metadata in place. We will talk about file upload using iForm file and iForm file collection. This was something that was missing in minimal APIs in .NET 6, but that's been fixed for us, and we can have a little demo of that. So if I go in, suppose I want to have a facility where I want to upload an image for the user in my, the person in my database, I can have an endpoint for that too. So I'm using a map post method with the URL person, upload with the ID of the person coming in the route template. Again, the ID infers from the parameter binding using from the route template. And then I've got the image file, which is my image which contains the information which is going to be uploaded, and of course the repository, and I'm just copying that file to the server. So if I go and run the Swagger, so run the project and come up with Swagger, what I have is this endpoint, and I'm suggesting an ID of 1 because I know that is me, and I'm going to upload a file. I've got a photo of me somewhere. That's it. That's uploaded. It's a quick and dirty API that I've put together, but I should have that image uploaded into the server here. So that is the image that I just uploaded. So that is file upload using iForm file and iForm file collection. So if you want to upload multiple files all at once, you can use the iForm file collection. The next thing is binding arrays and string values from header and query strings. So this means that you can send in a list of query strings with your endpoint, and that gets then bound to an array rather than a one-by-one parameter. So I've got some code for that too. So if I stop this, bind arrays. So I've got a filter by ID going on. So I want to send in a list of IDs and get information about persons corresponding to that ID. I can send in that using query string parameters, and all of my query string parameters gets mapped to this array of integers here, and then I can use my repository methods to get a list of such people. So let's see that in action. Let's say 1 and 3 maybe. So I'm sending 2 IDs and I'm getting information about 2 different people here. So that is parameter binding into string to arrays of primitives for you. The next one I want to talk about is the support for filters. Now this is a big feature that came up with minimal APIs in .NET 7. It can be thought of like iAction filters, but on the middleware level. But this is incredibly useful because if you want to run business logic before or after execution of the request handlers, this is what you need to be looking at. So you can log on a per endpoint basis. You can even short circuit an operation saying that do not go further. Like if you want special headers coming in, that's a place to do that. You can inspect whether there is authentication and authorization information coming in. You can modify the response as well. So it's a lot of functionality captured into one filter for you. Let's have a look at some of the use cases as well. Again, model validation, that was something which was tricky to implement, I think, in .NET 6, but now these filters are the go-to method to have model validation in place for minimal APIs. So let's go and see that in action. So what I have is an endpoint filter here. What it does is it logs some information into the logs for me. So if you want to create an endpoint filter, the add endpoint filter extension method is your friend. It accepts a delegate, which needs an invocation context object and a next object. So the invocation context is an endpoint filter invocation context object. Simply put, it contains all the contextual information. So if you want to access the HTTP context, the request response, the arguments for your route handlers, the invocation context can help you. And the next object, the delegate, it goes in and invokes the next endpoint filter in the list, because you can chain these filters. So it goes and invokes the next filter. Or if you are looking at the last filter that's been registered, it actually goes and invokes the route handler for you. So in this code, what I'm doing is I'm logging some information about the path, the method, the headers. You have access to all that in your endpoint filters. So if I quickly run that, so it's my filter by ID. I'm going to just try out with 1 integer. It's executed, but it's in this console window that you can see what's going on. So the path is being logged, the method is being logged, you get access to all the headers, all of that information with your endpoint filters. We can short circuit an operation as well. Like you can say completely stop whatever you're doing. I don't want you to hit the endpoint filter at all. So that again can be done by some code. So I have got this map get method here where I'm searching for a name. So typically it just sends back the name that I have got in my route template. But inside the endpoint filter, what I'm doing is I am getting the route value using the invocation context object. And I can say that if this thing, the name that comes in is something like Voldemort, completely stop executing, do not send anything back, and just send back this result. Death Eaters are here. So this is good. What I can do is I can have the endpoint filters, like the logging filters, applied to each and every endpoint in my minimal API. But that's your program.cs getting bigger and bigger. There enters one of the new features that's been introduced, and it's available for both controllers and minimal APIs, which is map group. So with map group, what you can do is you can organize a set of endpoints with a single prefix. So what I can do is something like this, where I create a variable for my group. So what I'm saying is I'm setting up a route group called the person endpoint group, and it's got a prefix of /person. So whatever is in the app map get with the prefix person gets replaced with the person endpoint group. I can take out the person completely from there. Sorry, this is going to be a bit tricky without my mouse, which has stopped working for some reason. There we go. I'm just going to comment this out because I don't want to be going and changing a lot of things. So that is it. That's my group setup. Now all my endpoints are organized into that group for me, and if I want to then apply authentication or logging to all my endpoints, I can do it at the group level rather than at the actual endpoint level, which is quite handy, keeps my code dry as well. So if I go in and try that out, nothing has changed. It's getting me the results back. But now I can go in and set up an endpoint filter. I'm going to show you another way of setting up an endpoint filter this time. Let's go in and set up the exact endpoint filter for logging in a different way. I'm doing it in the same file. What I can do is to create a logging filter, I can inherit from the iEndpoint filter class. I can inject any of the services that I need, in this case the logger, and I can give an implementation to the invoke async method with the code that I need. And then what I can do is on my person endpoint group here, I can apply that filter. Point filter, logging filter, that was the name. So like so I can apply it to the entire group as well. So that is a quick whirlwind tour of minimal APIs. But before we finish, we discussed route groups. There are more things in .NET 7 with minimal APIs. There's better open API support, so you can annotate your APIs and have that metadata in your open API documentation. You can enable parameter binding to types, so you can send in a couple of parameters and bind it to a single type using the asParameters attribute. There's support for problem details, which is a nice and friendly way of creating error messages, a standard way. You can even bind your request body a stream or pipe reader. Talking about middleware, I wanted to have middleware demos as well, but I would be out of time. But any standard middleware that you have for ASP.NET Core, you can apply that in minimal APIs. That even goes to the new rate limiting, caching, the authentication, all of that. Use cases, minimal APIs have been said to be more performant than controllers. So if you are in need of high performant microservices, by all means go for minimal APIs. There's also prototype APIs, quick APIs. Minimal APIs can be a really good example for that. What about controllers? Controllers are going to stay. It's not going to go anywhere because what minimal APIs gives you is like a choice between controllers and minimal APIs. If you want to start off small, you can have the minimal APIs, and as your application progresses and gets big, you can start moving code into controllers if you want. But if you want all the bells and whistles, then go in for your API controllers. Minimal APIs is here to stay. MVC is here to stay. It's all about having that choice. There's no reason why you cannot have controllers and minimal APIs in the same project. So that is it from me. That's my resources for the day. Talking about minimal APIs in Umbraco, I know currently it's a bit of a hack to get the minimal hosting model working in Umbraco, but by all means, you can use the map methods. That it doesn't stop you from using that. But I know there is work in progress to get Umbraco into the minimal API, minimal hosting model realm as well, where we can use the full feature set of minimal APIs. So that's it from me today. Thank you.